Okay, so the last thing that we're going to be talking about tonight are parametric equations. Now, parametric equations of circles. Now, parametric equations of circles are a little bit different to just the regular ones, okay? So this time we're actually going to define what our parametric parts are of the circle, and it's pretty much straightforward if you've just come straight from a trig topic. So, with circles, while the circle is not a function itself, we can still write it in parametric form, okay? So to do so, we're going to look at the unit circle, okay? So to remind you guys of the unit circle, in fact, I did this the wrong way around. There's always a trick, I remember, when doing the unit circle. Start off by drawing a circle that is okay. That's okay. Then draw your Cartesian plane over the top, like that, okay? Just makes it a little bit easier. Now, looking at this Cartesian plane here, what we're going to, and with this circle equation, we're going to define our circle. So, you might remember this from trig, okay? Our radius, we're going to call r, is 1 unit long, okay? And so, if we use this angle in here, we can define our values of x. So, whoop, that's not x. Our values of y, our height between from 0 to the point on my unit circle here. Okay, so this is my point. And we can also decide the length x as the following. And we're going to use trig. Okay, so my 1 unit, or r for my radius, as we remember. Okay, and we'll talk about r in a moment. So we'll just focus on the 1 unit for now. So theta, or sine of theta, is equal to y over 1. So sine theta is just y. And cos theta is equal to x over 1. Or cos theta is just equal to x. Okay, so using these two, so y and x is equal to sine theta and cos theta. So we're relating y and x by the angle of which my radius makes with the circle. Okay. Now, what we're going to do is to relate x and y directly, so the two equations x and y, to relate them directly. Far out, this is so touchy. To relate x and y, we're going to use Pythagoras. And we know that x squared plus y squared is equal to the length squared, or 1. Okay, so if I come back and have a look at my unit circle, what I'm saying is that the y value, the height, plus the x, remembering this is a right angle triangle. Okay, my y and my x squared, so the sum of my x squared and my y squared is just the sum of the radius, in this case 1, squared. Okay, so I'm going to use that Pythagorean equation. So what we can do is we can substitute x and y into this Pythagorean identity. Okay, so the x is just cos theta, so cos squared theta plus sine squared theta is equal to 1 as well. And so that's by subbing x is equal to cos and y is equal to sine of that. Okay, so just doing a simple substitution, we get this Pythagorean identity where cos squared, or the sum of cos squared and the sine squared, is equal to 1 as well. So the Pythagorean identity, we already know cos squared plus sine squared is equal to 1. And we can use this to convert between the parametric and Cartesian equations of a circle. Okay, and so that's what we're going to be doing in the following examples. Now, remembering that our r, our radius, is also a part of this too. So if we were to generalize this even further, so it wasn't the Cartesian equation, okay, so remember, if now we use r instead of 1, okay, so sine theta becomes okay, y over, in this case, my radius, which is r. So what I'm saying is, instead of this being 1 unit up here now in my circle, instead of this being 1 unit, okay, we're going to say this is any unit r. So the radius, it's radius long. So it could be 2 units long, it could be 4 units long, it could be 100 units long. This is for everything. So the first ones were for just when it was 1 unit long. This is for when it is any unit long. Okay, so sine theta is defined as y is equal y over r, and cos is defined as x over r. Now, doing the same rearrangement, this time we're going to get r sine theta is equal to y, and r cos theta is equal to x. So for any circle, my parametric equations become x is equal to r cos theta, and y is equal to r sine theta. So x and y are both related by r and theta in this case. So the radius of my circle, okay, which doesn't change depending on my x or my y value, and the angle that it makes. So both x and y depend on what the radius is and what the angle I am using is. So using that same Pythagorean triad that we used before, the x squared, so the x squared plus y squared is equal to, in this case it's going to be r squared because the radius is what our hypotenuse is. Okay, so x squared plus y squared is equal to r squared. Just substitute those values in again, so we're going to get r squared is equal to, or r squared cos squared theta plus r squared sine squared theta is equal to r squared. And then again, if we divide through by r squared, we just get cos squared theta plus r sine squared theta is equal to 1. Okay, nice and cool. So let's have a look and see some examples of this. So what we're going to do first is going to convert the parametric equations, x is equal to 5 sine theta and y is equal to 5 cos theta, to Cartesian form and sketch its graph. Now, you'll notice straight away that in this case, okay, we've got x is equal to 5 sine of theta. So this is where the r starts to play in. So the r is already there. We're going to do something with that. So let's get the pen ready. Let's do it. Let's start off with our two equations. X is equal to 5 sine theta. And our second equation is y is equal to 5 cos theta. What I'm going to do is make sine theta the subject of 1. So make sine theta the subject of equation 1. And we'll call this equation 1 and we'll call this equation 2. So in 2, so make sine theta the subject of equation 1. Okay, so to do so, we're going to go, so sine theta is equal to x on 5. Okay, what we're going to do is we're also going to make cos theta the subject of its own one as well. So coming down, get my pen ready, and I'm going to go, ooh, that's not what I wanted at all. Make cos theta the subject of equation 2. So that's going to become cos theta is equal to y on 5. Okay. Now we're going to substitute these into the identity cos squared theta plus sine squared theta is equal to 1. So sub into cos squared theta plus sine squared theta is equal to 1. Okay. So we're going to substitute these two values into that gotta stop doing that, into that identity, because remember that's the way we're going to relate cos and sine. Okay, so we're going to put them into that. So cos squared theta becomes y over 5 all squared plus sine squared, well that's x over 5 all squared, and that's equal to 1. Okay, so expanding this out, we get y squared on 25 plus x squared on 25 is equal to 1. And we're going to multiply through by 25. So we get y squared plus x squared is equal to 25. So this, therefore, this is a circle. So a circle with center, okay, 0, 0, because it's center at the origin, and radius 5. So now that we can go, now that we've been asked to draw it, we can do it quite easily. So we just know that it is a circle, so like that. Center is in the middle. Okay, and the radius, in this case, is 5. And that's pretty much it, okay? Yeah, so, obviously, you try and draw your circles better than I do, because mine are horrible. But that's pretty much it. Okay, oh, for God's sakes. Come on, buddy. You can do it. Alright, let's go and have a look at question B. Find the Cartesian form of the equation for x is equal to 4 plus 3 cos theta, y is equal to 3 plus 3 sine theta, and describe its shape. Okay, so considering what section this is in, didn't want to go that far down. Considering what this section is in, you could probably have a guess to what type of shape it's going to be. But let's have a look anyway. So our two equations are x is equal to 4 plus 3 cos theta, and we're going to call that equation 1, and y is equal to 3 plus 3 sine theta. Now you'll notice straight away that the only thing that changes is that number that's out the front. The radius, or the number in front of the cos and the sine, is going to stay the same for all of these. If we get something different, that's when we're going to run into a few issues, and we're not going to get that, so we don't need to worry about that. So, let's continue this going, and we're going to rearrange sine and cos. Oh, sorry, x and y for sine and cos, so we can substitute them back into that identity. So, step 1 is make cos theta the subject of 1. Okay, so to do so, x is equal to 4 plus 3 cos theta. Subtract 4 from both sides, you get x minus 4 is equal to 3 cos theta. Okay, divide by 3, we're going to get x minus 4 on 3 is equal to cos theta. Step 2, you could probably almost guess at this point what we're going to do. And if you guessed, rearrange or make sine theta the subject of 2, then you are 100% correct. So y is equal to 3 plus 3 sine theta. Okay, so y minus 3 is equal to 3 sine theta, and so sine theta is equal to y minus 3 on 3. Okay. Now, once we've done that, what we're going to do is we're going to we're going to substitute, for God's sakes, we're going to substitute sine and cosine into our trigonometric identity. So sub cos theta and sine theta into, okay, so it's going to be cos squared theta plus sine squared theta is equal to 1. Okay, so substituting our values in, we're going to get, so x minus 4 on 3 all squared, okay, for that bit, and then we're going to get plus, and it's going to be y minus 3 on 3 all squared for that bit, and that's going to be equal to 1. So expanding this out, we're going to get x minus 4 squared on, not 3, that should be a 9 in this case, because 3 squared is equal to 9. Okay, plus, and this part's going to be y minus 3 all squared is also equal to 9 there too, and that is equal to 1. Now what we're going to do is we're going to multiply through by 9, and we're going to get x minus 4 squared plus y minus 3 squared is equal to 9. Now that we've done this, okay, what we can do is not go back to the menu. What we can do is we can then say the stuff that we know about this circle. So we know that it is a circle. Okay, we know it is a circle with center. So remember, we replace the value, okay, with the negative h, negative k, or h and k, so it's x minus h and x minus k, with h and k being the value of left and right and up and down that it has moved. So in this case, it is a circle with center 4 and 3. Okay, so again, the values where x squared and y squared is equal to 0. And radius. And the radius in this case is equal to 3. Okay, so r squared is equal to 9, so r is equal to 3. Okay, last part of this topic. So let's go up. It's not letting me go up. Why aren't you letting me go up? You always let me go up. Up, please. That's not up. Why have we decided to do this now and not in the 400 times that we did something earlier? Okay, my thing is busted. Okay, I'm going to try the hard way. Whatever. I'm just going to read it out. Wow, this is literally not working at all. I am so glad technology is on my side tonight. Does this mean I'm going to have to do this whole video again? We will only find out. No, we don't have to. I can use the mouse. Okay. Forgot about the old mouse. Okay, so the last question says, write x squared plus 2x plus y squared minus 4y minus 4 is equal to 0. I'm sure there's meant to be another part of that question, and it just says in parametric form, so we can quickly add that. It's good to always wait for the last question, or the last part of the video, to actually make all the stuff up. So we're going to write this in parametric form, okay? So what I'll do is I'll scroll down again and I'll rewrite out that equation. So let's go down. Okay, so this is part C. Okay, so our equation is x squared plus 2x plus y minus 4y minus 4 is equal to 0. So this is our equation. So what we need to do is we're going to put it into the circle form by completing the square. And we're going to put it into the form x minus h all squared plus y minus k all squared is equal to r squared. Okay, so what I'm going to do first up is I'm going to move all of the consonants to the right hand, constants, not consonants, the constants to the right hand side. So it's going to leave us with x squared plus 2x plus y minus 4y is equal to 4. Okay, now what we're going to do is we're going to complete the square on x and complete the square on y. So to complete the square on x, we go x squared plus 2x. Okay, half of 2x is 1x, 1x squared is 1. Okay, so we add 1 there, and we add 1 on this side. Okay, and then the other bit is plus, so y squared minus 4y. Okay, half of 4y is negative 2, and then negative 2 squared is just 4 as well, so add 4 and add 4 there. Okay, so x squared plus 2x plus 1 factorizes to give us x squared plus 1, because half of 2x is just 1, or not x, sorry, that's a complete and total lie. It should be x plus 1 all squared, because x plus 1 all squared is x squared plus 2x plus 1. Okay, plus, and in this one I get y, and then half of negative 4y is, no, sorry, half of negative 4 is negative 2. So negative 2 goes in there, all squared, and that is equal to 9. So therefore, this is the equation of x, oh sorry, this is a circle. We don't actually write this, but we can say it. Therefore, this is an equation of a circle with x plus 1, so negative 1, and 2 as the center with radius 3. But what we're going to do is we're going to divide this all by 9. Okay? Actually, no, we won't do that. We'll do it this way. So remember that. Okay? So remember. So this is us going back in reverse. So what we need to remember is that x is equal to, and we're going to use the version with the radius there because the radius is going to help us a lot. Okay? And r is equal to r sine theta. Okay, so remember that our radius exists and that x is equal to r cos theta and y is equal to r sine theta. Okay, so in this case, actually, do I want the r? Yes, I do. Now, in this case, okay, we've got x plus 1 all squared. Okay, so remember when we went back in reverse, or when we were going the first way, the whatever appeared on top was in our x values, okay? So we know in this case that cos squared plus sine squared theta is equal to 1. So what we're going to do is we're going to let x plus 1 over 3 be equal to cos. So the first bit is going to be equal to cos. So x plus 1 all squared. No, I don't want to... I've kind of stuffed this up a little bit. Okay. Let me take it just a step back for a moment. So some intense scribbling out there. Okay, what I'm going to do is I'm going to divide all of this by 9. Okay, so what I'm going to get is I'm going to get x plus 1 all squared over 9 plus y minus 2 all squared over 9 is equal to 1. So if I divide everything through by 9. Okay, so once I do that, okay, once I divide everything by 9, so once I divide everything by 9, what I'm going to do is I'm going to turn this back into squares, okay? So 9 squared, 9 is the same as 3 squared. So this is going to be x plus 1 all squared over 3 squared plus y minus 2 all squared over 3 squared. Now, the reason I want the squares on the bottom and the top is now because I can rewrite this as x plus 1 over 3 all squared plus y minus 2 over 3 all squared, and that's equal to 1. Now, we're going to remember, this is where we're going to remember. Okay, remember that we have this trigonometric identity where cos squared theta plus sine squared theta is equal to 1. And also that x is equal to cos and y is equal to sine theta. Here I was missing something. Okay, so if we've got x is equal to cos and y is equal to sine, and we also know that cos squared is equal to theta, cos squared theta plus sine squared theta is equal to 1. Well, we've got two things in the above, in the third last column, where we've got two things, or we've got something squared plus something squared is equal to 1. So it would be worth to write that, I've just lost my mouse. It would be worth to then write, let me just go a little bit up because I just need this bit here. Okay, so what I could write is that, therefore, we can say, okay, let cos theta be equal to the x bit. So x plus 1 over 3. So if we let cos squared be equal to x plus 1 over 3 squared, okay, so I'll just write it this way for this one, then cos theta is just equal to x plus 1 over 3, okay, just like that. And it's the same for the sine one as well. So let sine, I'll do the whole thing, equal to, okay, y minus 2 over 3 all squared. So then sine theta is equal to y minus 2 over 3. So it's just like taking the square roots of both sides. Okay, now we've got x theta is equal to x plus 1 over 3, and cos theta is equal to x plus 1 over 3, and sine theta is equal to y minus 2 over 3. What we're going to do now is we're just going to rearrange these to get x and y by themselves, and then we're done. So for the left-hand side, we're going to get 3 cos theta is equal to x plus 1. So then 3 cos theta minus 3 cos theta minus 1 is equal to x. And on the right-hand side, doing rearranging as well, we're going to get 3 sine theta is equal to y minus 2. And so 3 sine theta plus 2 is equal to y. Okay, and so therefore our parametric equations are x is equal to 3 cos theta minus 1 and y is equal to 3 sine theta plus 2. So that one was just reverse engineering that one, okay? And that is the last part that we need to do, okay? So with that being said, we can generalize what we've just done with two formulas, okay? So the parametric equation of a circle with center 0, 0 and radius r, and so this is like your shortcut. X is equal to r cos theta and y is equal to r sine theta, and blah 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 with a, b, so the center is somewhere else, and radius r, x is equal to a plus r cos theta and y is equal to b plus sine theta with an r there. Okay, so that's pretty much it for this parametrization. Quite hard. Well, not quite hard, but, you know, quite a bit of work to think about. A little bit to think about while we do this, okay? With that being said, that's the end of the parametric equations, and that finishes off our first extension topic completely, which is the further graphs. Any questions, please make sure you ask, either in the Google Classroom or in person. I shall see you guys in the next video.